My view about the safety of the LHC is very simple. The LHC is safe. There is absolutely no scientific basis whatsoever for any fears about anything dangerous that might be produced by the LHC. But let me tell you why I feel so sure about this. What the LHC is going to be doing is recreating, under controlled laboratory conditions, collisions that have been made on Earth for billions of years by cosmic rays coming from outer space. All the time, continuously, the Earth is bombarded by cosmic rays. And many of these cosmic rays have energies which are far beyond what the LHC is going to be able to achieve. And the Earth has never disappeared, the Sun doesn't disappear, other astronomical bodies don't disappear. The beam is made up out of an enormous number of individual particles, and each individual particle only has about as much energy as a mosquito. So when we talk about incredibly high energy collisions of protons, we're actually talking about colliding pairs of mosquitoes. We did a detailed study of the possibilities a couple of months ago. This was reviewed by an external committee of scientists, including a Nobel Prize winner. They've given us a clean bill of health. The beam goes around in a little tube inside the magnets. If it got out of that little tube and hit a magnet, it would bore a hole straight through that magnet. And since each magnet costs us something like £1,000,000 Swiss francs, we don't want to make too many holes in the magnets. Then, beyond the Standard Model, the astronomers and the astrophysicists tell us that the universe is full of matter, of stuff, cold dark matter, that's never been seen. Presumably not the same sort of particles that make up the Standard Model. So, within the Standard Model and beyond the Standard Model, we theorists think there must be something new to be discovered at the LHC. Now, as far as the dark matter is concerned, that's a different challenge. It's a little bit like the Sherlock Holmes story, where the most important clue was the dog that did not bark. Because the point about dark matter is that you can't see it. So how do you detect it if you can't see it? So we've been discussing with our experimental friends how exactly this dark matter should appear, what other processes might give you these funny events with nothing happening. One is going to get probably some glimpses of things that people have never seen before with lower energy accelerators. thing about the LHC is it's really taking us somewhere where no accelerator has ever been before. There must be something new there. And finally, we're going to get the answers. And the really exciting thing is, okay, we're going to get the answers, but we don't know what the answers will be.
What would you say the most significant discovery here has been so far?
I think the two biggest discoveries were the discovery of a new form of radioactivity, what we call neutral currents, back in 1973, and the discovery of the particles that carry the weak interactions, the W and Z particles, which happened in 1983. Those are probably the biggest moments.
What would you like to see? What would be the thing that would excite you most?
The thing I would most like to see is something which is not contained in any of the meters-high piles of paper sitting on my desk. Of course, it is true that the sort of mathematics and sort of physical concepts that we use in particle physics may seem rather abstruse. In fact, sometimes they seem pretty damn abstruse to me as well. I think that somehow it's a job of a physicist to look for a theory of everything. Because if you say from the beginning, well, I'm going to be content with some theory that explains a little bit but leaves a whole lot of the rest unanswered, I think you're just not earning your paycheck. Well, the LHC would be the first accelerator which has an energy high enough to make these supersymmetric particles. And therefore it could make these particles of dark matter. And so in fact a lot of my personal research work is centered on trying to figure out how experimentally you would try to detect these supersymmetric particles, and in particular these dark matter particles. So I have high hopes of understanding dark matter with the LHC. The LHC is going places that no accelerator has ever gone before. But the really exciting thing is that it's going to explore, some terra incognita that nobody's explored before. And there's all sorts of good reasons for thinking there's a really exciting, dragons and other monsters there. Precisely which dragons and which monsters, we won't know until the LHC starts up.